Section 1.1, lines in the plane, day 2. Here we have an example word problem. During 2006, Research and Motion's net profits were $631.6 million, and in 2007, net profits were $1293.9 million. Write a linear equation giving the net profits in terms of the year X, where the year 2006 is year 6, and then use the equation to predict the net profits in 2008. Okay, so the information that's given, we need to find the equation of a line. We're writing a linear equation. And when we write an equation of a line, you know that we need a point and a slope. So our point is going to be an XY coordinate, and in the problem it tells us that X is the year and Y is going to be the net profits. So we can see in the year 2006, which is year 6, our net profits were $631.6 million. And in the year 2007, which is year 7, our net profits were $1293.9. Since we want to write the equation of a line and we have these 2 points and we need a point and a slope to write that equation, we're going to find the slope of this 2 points. So we'll use our slope formula. Which is going to give us a slope of 662.3 over 1, which is just 662.3. So that's our slope. In order to write the equation of the line, we need y minus y1 equals m times x minus x1. That's our point slope formula. We can pick either point. I'll pick the first point. We'll use y minus 631.6. is equal to our slope of 662.3 x minus 6. And we'll simplify this equation. And our equation of our line will be y equals 662.3x minus 3342.2. So that answers the first part of the problem here. That's our equation of our line representing our profits. And then we will answer the second part of the equation where we use the equation to predict the net profits for the year 2008. So the year 2008, that means that x would be equal to 8. So we'll take our equation and we'll substitute 8 for x to calculate what the profits would be approximately in that year. And it looks like our profits will be $1956.2 million. In our next example, we want to use the slope-intercept form, which you should know is y equals mx plus b. We want to determine the slope and y-intercept of each of the equations given and then describe the graph. So our first equation, we have the equation x plus y equals 2. So we'll get that equation in slope-intercept form by subtracting x. This tells us that our slope is -1. And our b value, which is our intercept, is 2, which makes our y-intercept the point 0.02. This is where the graph hits the y-axis. Because our slope is -1, and it's a negative slope, that means that this line is falling. In example 2, we have the equation y equals 2. Here our slope would be 0. And we know that our slope of 0 represents a horizontal line. And if you think about this, if you had this equation, y equals 2, here's your horizontal line, this has a y-intercept of 0, 2. It's hitting the x-axis at 0, 2. So that would be your b value. If you're looking at your equation y equals mx plus b, only your b value was here. Your slope was 0. Therefore, our description would be horizontal, our slope would be 0, and our y-intercept would be 0, 2. Here we have example of parallel lines. We want to find the slope-intercept form of the line that passes through the point 2, negative 1, and is parallel to the line 2x minus 3y equals 5. So again, we want to write the equation of the line. When we write the equation of a line, you need a point and a slope. So our point is going to be the point 2, negative 1. And then we need the slope for that line that's parallel to this line, 2x minus 3y equals 5. So what we want to do is we want to put 2x minus 3y, this equation, we want to put this in slope-intercept form. So we'll solve this for y, and y will be equal to 2/3 x minus 5/3. Our slope will be 2/3. So if we go back to try and write the equation of the line that goes through the point 2, 1, and is parallel to this line, we'll use the point 2, negative 1, and we're going to use the slope of 2/3 as well, because parallel lines have the same slope. So we'll use our point slope formula. And we'll use y plus 1 equals 2/3 x minus 2. We'll distribute 2/3 x minus 4/3, and then we'll subtract 1, and this will give us minus 7/3. So the equation of the line that goes through the point 2, negative 1, and is parallel to 2x minus 3y equals 5 will be this equation, y equals 2/3 x minus 7/3. Here we want to talk about perpendicular lines. We're going to find the slope-intercept form of the equation of the line passing through 2, negative 1. That's perpendicular to 2x minus 3y equals 5. If we were looking at the last example, this information is the same. The only thing we've changed is we've changed it to perpendicular. We would start off the same way. You would take the equation, put that in slope-intercept form, and identify the slope. We said the slope was 2/3. Because these lines are perpendicular, they have opposite reciprocal slopes, so you want to use the slope of negative 3/2. So we'll use the slope of negative 3/2 and the point 2, negative 1, and we will go back and put that into point slope and substitute those values. So we have y plus 1 equals negative 3/2 x minus 2. We'll distribute again, negative 3/2 x plus 3, and then we'll subtract 1, and this will give us the equation of the line that passes through the point 2, negative 1, that is perpendicular to this line, 2x minus 3y equals 5. We have y equals negative 3/2 x plus 2.